Today I'll be going over the ball mill design for the pretreatment process for the ethanol, switchgrass to ethanol. My teammates are Bradley Newman and Joshua Ryan. I'll give a brief overview of design of the equipment, decision of why I chose the variables for the ball mill, followed by a conclusion. Basically, the ball mill had to decide on how the dry biomass can be broken down in the process, whether by using a chipping, grinding, or milling process. I also had to determine the opening side, which is the side in which the dry biomass will have to enter through the mill, and also a bond work index, which is the energy required for the mill to break down the dry biomass in order to enter into the gasification stage. In order for the gasification process to be effective, a reduction of size of switchgrass is needed. Basically, the smaller the better. This requires a greater bond index, which will also have an effect on the cost for the ball mill. Large enough setting for the dry biomass to pass through the ball mill will need to be set, which is basically the opening side first. A ball mill was chosen. The reason for this is I did research on it, and facts showed that it's more effective in size breakdown for the switchgrass. Opening side of 10 centimeters was chosen, and a switchgrass size of 10 millimeters was also chosen, which was required to choose a bond work index of 30 kilowatts per newton. If I chose a lower bond index below 30 kilowatts per newton, it will only break down switchgrass between 3 millimeters to 6 millimeters. So you have to have a higher bond work index. So basically, in conclusion, a higher bond work index was chosen in order to break down the switchgrass for the ball mill. Smaller particles for the switchgrass was needed in order for an effective gasification process to work. And left to be done on our project is to finish sizing certain materials, economic analysis, finish optimization of the whole switchgrass to ethanol process, and a report/poster. And that's it.